About half a century before Newton developed his great theory of motion, a German astronomer called Johannes Kepler, I'm kidding, I don't know how to say his name, Johann probably. Johannes Kepler developed a very detailed description of how the planets fly around the sun. And how he did this was very impressive. He didn't have a telescope. He tracked the stars in the sky with data, and he used math. From his observations over years and years, he developed his laws of planetary motion. The first law is that planets move in ellipses, or ellipses. Basically, they don't orbit in perfect circles. They orbit in more like ovals. The third law is that planets orbiting the sun will speed up when they're closer and slow down when they're further. The third law is that the orbital period, so how long it takes for you to orbit the sun, depends on how far you are from the sun. So like Pluto takes way longer than Earth because Earth is closer to the sun. This means that the time it takes to orbit the sun is related to your distance in a very predictable way. Mathematically, the third law is this. The ratio between the orbital times of the two planets squared is equal to the ratio of the two distances from the sun cubed. And a variation of it is s cubed divided by time squared 1 is equal to s cubed 2 of the second time squared. Let me give you an example. Let's find Jupiter. So if you Google it, Jupiter orbit is 11.86 Earth years. Let's find its distance from the sun with Earth as a reference. So the time of Jupiter divided by the time of Earth squared is equal to the distance from the sun, so the orbital radius of Jupiter, divided by the orbital radius of Earth cubed. You get this as 11.86 squared equals the orbital radius of Jupiter cubed. Now we're going to learn a new unit of measurement. This solves as the distance of Jupiter from the sun is equal to 5.2 AU. AU means astronomical units. So that means Jupiter from the sun is 5.2 times further than Earth is from the sun. By the way, something that really helps me is having all the formulas you ever need in one place. And I make these cheat sheets for myself, and if you want your own, it's in the description for free. So go sign up.